For 20 years, one machine decided who got to build the future of computing, and China wasn't allowed to touch it. That machine is built by a Dutch company called ASML. It costs around $200 million per unit, and it uses light so precise it can carve circuits smaller than a virus. Without it, engineers were told, you simply cannot make an advanced chip. Full stop, no workaround. And starting in 2019, tightening hard by 2022, the United States made sure Huawei and its chipmaker SMIC would never get one. So Huawei did something nobody expected. They stopped trying to buy the machine and started asking whether they even needed it. Here's the setup you need to actually understand what happened. Since 1965, the entire chip industry ran on one idea. An observation made by Gordon Moore that the number of transistors on a chip roughly doubles every 2 years. That idea, later called Moore's Law, built the modern world. Phones more powerful than the room-sized supercomputers of the 1970s. But that streak has been quietly dying. TSMC, the company that makes chips for Apple and Nvidia, is reportedly fighting for something like a 6% improvement in its next generation. That used to be 50% or more. The easy gains are gone. And for Huawei specifically, the problem wasn't just that progress industry-wide was slowing. It was that the one tool everyone else still had access to, Huawei didn't. Then, on May 25, 2026, at the EE International Symposium on Circuits and Systems in Shanghai, a woman named He Tingbo, president of Huawei's Semiconductor business unit, walked on stage and presented something called the Tau scaling law. And this is the part that actually matters, so pay attention. Modern chips are not slow because the transistors themselves are slow. They're slow because of how long it takes information to physically travel across the chip. Huawei has said that in a modern computing system, more than 80% of the energy spent goes toward moving data around, not doing the actual math. The workers are fast. The roads between them are the problem. Every signal that travels down a wire fights resistance and has to fill an electrical charge like a bucket, over and over, millions of times a second. So Huawei's engineers asked a different question. If the problem is distance, what if you just make the distances shorter, not by shrinking the transistors, but by rearranging where they physically sit? Take a page of text and fold it in half. Words that used to be centimeters apart now sit right next to each other. That's the idea behind Huawei's new architecture, called LogicFolding. Instead of laying a chip out flat, they split it and fold one half directly on top of the other. So signals that used to travel across millimeters of flat silicon now only travel a fraction of that distance, moving straight up instead of sideways. And here's where it stops being theory. Huawei revealed they had already quietly designed and mass-produced 381 separate chips using principles related to this approach over the past 6 years before any of this became public. The first commercial chip to fully use LogicFolding will be a new Kirin processor launching this fall in 2026. According to Huawei's own published data, that chip reaches a transistor density of 238 million transistors per square millimeter, up from about 155 million on the current Kirin 9030 Pro, a jump of roughly 55%. It came from folding the layout itself. Now, before you get too excited, here's the number that actually made semiconductor engineers sit up, and it's not the flashy one. It's 1.5 micrometers. That's the bonding pitch Huawei says it's currently hitting, the spacing between the tiny copper connections that let two stacked chip layers talk to each other. Right now, the best publicly known bonding pitch in the industry sits somewhere around 9 to 10 micrometers. Markets noticed immediately, on the day of the announcement. Shares of SMIC and Huahong Semiconductor both jumped roughly 7 to 8% on the Hong Kong exchange. But here's the honest part, the part a lot of headlines skipped. Huawei's roadmap talks about matching a 1.4 nanometer class chip by 2031, and that number needs a caveat. Still genuinely impressive, just not exactly the headline number.
Nvidia just lost $250 billion in a single trading session. Not because of a bad earnings report. Not a scandal, not a recall, nothing like that. It happened because of one Reuters story about a machine most people have never heard of, built by a company almost nobody had heard of a week ago. By the time the market closed that day, ASML, the Dutch company that has quietly controlled one of the most important choke points in global technology for almost 2 decades, had lost roughly 55 billion euros in value. Its stock fell more than 8%, dropping to around $1,659, its lowest point since early June. Samsung and SK Hynix, the two biggest memory chip makers on the planet, each fell more than 13%. SanDisk dropped close to 11%. South Korea's benchmark index, the KOSPI, plunged nearly 11% at one point and actually triggered an automatic trading halt to stop the panic from spiraling. AMD dropped more than 8%. Micron fell close to 6%. This wasn't a bad day for one company. This was the entire global chip industry flinching at once. So what actually caused this? A machine. China just started producing, in small numbers, one of the most important pieces of industrial equipment on Earth. The kind of machine that until very recently only one company on the planet could reliably build. Here's what most people get wrong first. Everyone assumes China was completely banned from buying these machines. That's not true. China bought a huge volume of ASML's equipment for years, at times making up close to 29% of ASML's total sales, worth around $9.5 billion in 2025 alone. What actually got restricted was the top tier. Now here's the part that actually moved markets. Reuters reported that a state-backed company out of Shanghai has begun mass production of its own immersion deep ultraviolet lithography systems, with first deliveries expected before the end of the year. The company is called Shanghai Yulongsheng Technology, founded back in 2022, built on roughly 1 billion yuan in registered capital. It barely has a public footprint. No website worth mentioning, no press office, nothing you can Google in 5 minutes, which tells you this was never meant to be a startup story, it was built quietly on purpose. Behind it sits Shanghai Electric and a subsidiary of Shanghai International Trust, and the engineering talent was pulled directly from Shanghai Microelectronics Equipment, China's long-running lithography effort. Plus, a team connected to Sicaria, the equipment maker tied to Huawei. This is not a garage operation. This is a national resource merger wearing a startup costume. The plan on the table is roughly 5 machines in 2026, scaling toward about 20 machines in 2027. And the first customers are already lined up. SMIC, China's largest chip foundry, Huawei Semiconductor, and CXMT, the country's leading memory maker, which reportedly just locked in a 5-year supply deal worth more than $7 billion with ByteDance as demand for AI memory explodes. So this isn't theoretical. There are real customers waiting with real money on the table. 5 machines is not a threat to ASML's business. ASML shipped somewhere around 130 immersion DUV systems in 2025 alone, on top of everything else in its lineup, and pulled in tens of billions in revenue doing it. It's also planning to grow its own DUV production capacity by 30% by 2027. So in pure output terms, 5 Chinese machines next to ASML's annual shipments is not even close to a fair fight yet. So why did the market panic like this was the end of the world? Because markets don't just price what's happening this year, they price what happens next. For almost 2 decades, ASML's monopoly was treated like an unbreakable wall, the kind of advantage that justified premium valuations across an entire industry. What does 5 machines look like when it becomes 50 in 3 years? Or 500 in 6? That's not a 5-machine story anymore. That's a trajectory story. And trajectories are exactly what move $500 billion valuations in a single trading session. So here's where this actually leaves us. This is not China defeating ASML this year, and anyone telling you that is skipping the real numbers. But it is very real proof that the wall everyone assumed was permanent now has a crack in it. And that crack was reportedly enough to wipe out $250 billion from Nvidia and tens of billions from ASML in a matter of hours. The next thing to actually watch isn't this year's 5 machines. It's whether CXMT, SMIC, and Huawei can run them reliably at scale. Because that's the moment this stops being a headline and starts being an industry.
Huawei just did something that chip experts said should not be possible right now. For 8 straight months, one of its most important laptops was running on secret silicon that nobody outside the company could confirm. No press release, no spec sheet, no announcement. Then one small software update ripped the secret wide open, and it turns out Huawei was hiding something big. The laptop is the MateBook Pro, and it launched all the way back in May 2025. From day one, buyers and reviewers noticed something strange. Huawei never listed the processor. Every other laptop maker on Earth brags about its chip on page 1 of the marketing. Huawei said nothing. That silence lasted 8 months, until the Harmony OS 6 update rolled out and quietly revealed the chip's name inside the system settings for the very first time. The chip is called the Kirin X90, and it is not a small deal. This is the same processor already confirmed to be running inside the MateBook Fold, which means Huawei built one chip to power its entire premium laptop lineup instead of designing something different for each device. That is a real strategy, not a one-off experiment. Here are the actual numbers. The Kirin X90 uses a 4+4+2 core layout, which adds up to 10 cores and 20 threads. 8 of those cores run at 2.31 GHz, 2 more run at 2.05 GHz, and the whole chip can burst up to a maximum of 4.2 GHz. That is a real hybrid design, mixing performance and efficiency cores the same way major chip makers do it, just built entirely by Huawei's own engineers. But the cores are not even the most interesting part. Huawei did not license a graphics chip from anyone else. It built its own, called the Malion 916 GPU, completely in-house. It also built its own NPU, the part of the chip that handles AI tasks like photo processing, voice recognition, and machine learning. That means Huawei now controls every major piece of this chip from the ground up, with zero dependence on outside graphics or AI hardware. Keep that number in your head, 0, because that is the whole reason this story matters. Now here is the part that should genuinely shock you. Back in 2019, Huawei was placed on the United States Entity List. That single move cut Huawei off from American technology completely. It could no longer buy chip design tools from companies like ARM without special permission, and it lost its manufacturing relationship with TSMC, the company that was actually building Huawei's most advanced chips at the time. On top of that, the Dutch company ASML, the only company on the planet capable of building the machines that make the smallest, most advanced chips using extreme ultraviolet light, was pressured to stop selling that equipment to China entirely. At that point, almost every analyst in the industry agreed on one thing. Without ASML's machines, Huawei and its manufacturing partner SMIC would get stuck making older, weaker chips forever, while the rest of the world kept racing ahead. The gap was supposed to widen every single year until it became impossible to close. Without access to the newest extreme ultraviolet machines, Chinese foundries have leaned on older deep ultraviolet equipment, using a technique where the same layer of a chip gets exposed multiple times to squeeze out more detail than the machine was originally built for. It is slower, it is more expensive, and it produces more failed chips along the way.